Alright. Another video. Just doing this in chunks. That's what I know it's turning into. So the idea is he wants us to find the pH of the body with just given these two things. And it seems kind of daunting initially because he's only giving you a concentration of bicarbonate and a partial pressure of CO2. So the idea is that you have to know how to convert this from this into this Henderson-Hasselbalch equation. Because once again, we're looking at pH is equal to pKa plus the log of base over acid. Again. So we're not doing anything different, but the idea is being able to know how to convert this information we're giving here to this. He said he would give us the constants, so knowing those constants makes this really easy. So the idea is that our pH being equal to pKa, which he gives us, is 6.1. He gave that to us in lecture. And so if you need to go in, it's in the buffer lecture, so if you need to go through it and look at that again, he should give us that. But if not, just know that the normal pKa of blood is 6.1. Or of, not of blood, but of H2CO3, which is carbonic acid. And then you're doing your log, and you're doing base over acid. So the idea is if this is our base, CO2 has to be our acid, right? So it's H2CO3 technically, but partial pressure of CO2 times by the constant gives you how much of that is going to be H2CO3. So we're using our concentration of 35 millimolar over 0.03 times by our partial pressure. So what we're saying here is that the acid part of it is 0.03 times our PCO2. Because this gives us a concentration of H2CO3. Okay? And then it's just plug and play from there into a calculator, and you should be able to get this. So then we do 35 divided by 0.03 times 50, and then we do the log of that. So that came out to 23.33 continued, or 23 and a third. You do the log of that, and that gives you, this part gives you 1.3679 plus some extra decimals that I'm not going to worry about. And then he gives us a pKa of 6.1, so you can just assume 6.10 to make it easy, because I'm assuming we're going to want those to two decimal places. So then you just add 6.1 to that, which gives us a pH of 7.4679, which is basically about 7.47 in terms of a pH. And then looking at C, I just did pick two. I just kind of going between C and B. It's the same basic principle. So the idea is that we're going to be doing pH is equal to pKa, which is 6.1, plus the log of HCO3 minus on top, so 20 millimolar, over 0.03, which is our constant, times by our partial pressure of CO2, which is 40 in this case. And then basically just plug and play into a calculator. So you do 20 divided by 0.003 times 40. When you're doing this, make sure that if you're putting it all in one, that you're using parentheses appropriately. So that gives us 16.6 for the ratio there, and then we're going to do the log of that, which gives us 1.2211 worry about it, because once again, we're not going that in depth. Plus 6.1 gives us a pH of 7.3218, which is approximately 7.32 for total pH on that. The idea is that, you know, if you're looking at your concentration of bicarbs and your partial pressure of CO2, how close are they to their like normal range? Like if you're thinking about like lab values, something like that. Yeah. So that's how you do these. Very simple, very straightforward. So